the reminder. Sure. All right, I'm recording now. So, Stephen, let me reiterate your question for the sake of people that will be watching this recording. Your question was, how does Transformer stack up in relation to all the other neural network architecture? And when we're saying Transformer is eating up all the other architecture, then what does that really mean? Right? So I was explaining that we used to have a specialized neural network architecture for a particular domain, specialized for a particular problem set. LSTM was helping us with language. We had weight decay and all those gradients problem. The stuff is forgetting important information once the context window is so long. It couldn't really do sophisticated stuff, but it was an advancement, right? And CNN was pretty good. It's still pretty good. Um, Applicable in a whole lot of things that we're doing today, right? We have other domain problem like the reinforcement learning. We didn't touch reinforcement learning at all, but reinforcement learning is pretty easy. You have an agent, you know, and then you have an environment, and the agent is acting within an environment, and you are rewarding actions that the agent is taking or punishing actions that the agent is taking, right? And with time the agent will learn the right actions or the best actions that is to be rewarded to get the maximum gain. Essentially, that's what reinforcement learning. So what we have seen is that with transformer you could get state of the art performance on all the modalities of all these problems, whether it is computer vision, whether it is language, whether it's reinforcement learning, whether it's time series, whether it is all this. And that is the core of what the wow factor of AI in the past few months or years. Because you no longer need to now deploy a single model for a single problem set. Now a single architecture can cater to all of that. And how is it doing this? The example we did last week was solving for language. That was language transformer because the inputs were word embeddings, right? Which you do all the necessary, all the layer. You added plenty layers to ensure that it's not losing any information resolution about the language or about the text that has been injected, right? That's what essentially they were, positional encoding, attention, and all of those things. That's essentially what they are doing, so that it can have a full representation of the context of the word that has been injected to the encoder, right? And that was how Transformer started in 2017, right? It was to solve language. But some people tried it, they injected audio array, and they realized that wow, so this thing still worked. They injected pixel data, it still worked. Some people, so they've been injected several things, and it has held up the same architecture, just swapping out some layers. So, for example, in a vision, if you're solving a vision problem with transformer, you wouldn't need, positional encoding. You wouldn't need, some of the layers that we talked about last week. Yeah, but point is encoding the representation of the information contained in the data allows for you to do a whole lot of sophisticated stuff at the decoder layer or even just at the encoder layer alone. And you asked a question last week that was about is transformer particularly about generative AI alone? While that is the answer to that will be yes. Transformers allow for the era of generative AI. Without transformer, we don't have the ability to do anything, right? Was a feature called neural network. The GAN. What's it? Is he something like that? I can't recall precisely what the generative adversarial is simply doing is that if you send it a picture of my face, for example, right? The neural network is during training, the objective of the neural network is to have it train, create a fake copy of that input data. And the loss function would be for the neural network to not be able to differentiate between the fake copy, the generated copy, and the original copy. So the more difference, the loss function is able to, calculate that, okay, it's not looking so much like the original. It will punish that and then use that as a optimization function. It's the same. Everything that we've done is still the same. There's a loss function, there's an optimization that now adjusts the weight, and then it goes again, it runs over it again, and then checks, okay, am I closer now? And until the of fake data is as close and indistinguishable there. When we were talking uh, customers having auto example, of the, and able to release the to not. So this is what the problem is, or is this so sorry, is it better now? I just switched my network. Okay, sorry about that. So that you know that GAN architecture is what led to applying the market for other generative problem sets. The aim of the model data sets that are indistinguishable the original data was trained with. It came with other problems like hallucination, right? Hallucination because things up. The model could make things as though they were real, not real. Different sets of problems. But the point is that it was a breakthrough. It was a breakthrough model. It was a breakthrough architecture in the sense that we can not only do classification or do regression or like all those things that we used to be able to do before. Now we could work our way backwards again from the model. We can work our way backward and generate some fake data that will look so real. And I'm saying fake data because it's actually synthetic, right? Those things are not real. They're synthetic, but they are value, right? Imagine what you could do with that. Am I still breaking? Oh, I guess the the ghost of poor network is moving around Nigeria today. Samuel, you may want to check your network. Okay. Yeah. All right. So that architecture was the breakthrough architecture that led to the era of Chat GPT from OpenAI, all the image generators, Mid Journey, and all those things that you're saying. And while the data is generating is fake, it's an attempt to go, before when training, you can go from your data set to a weight and bias model, right? All the numbers kept in your model. Well, now you can go from the model to generated data. We were never able to do that before. And, what we've seen is that transformer models are able to, they are more information dense, you know, they are able to represent, nuances available in the data much better. They are able to encode them much better because you have more flexibility around the encoder layer. It separates the encoder layer and then the decoder layer, right? So you have more flexibility in terms of what you can do uh, along those layers, right? So the there's an NLP task or problem set, for example, sentiment analysis. You want to decide whether you want to know whether a piece of text or a piece of tweet is positive or negative. If you were going to solve that problem the traditional way before transformer, you would have to, write a whole lot of boilerplate code, write a whole lot of, nonsense. Back then it wasn't nonsense, but now it's nonsense, right? You have to write a whole lot of all those things just to, tell whether something is positive or negative. But now with transformer, there's something called zero shot learning because the information, the model already understands the general representation of language, so you can easily tell. Zero shot means without retraining it, without telling it, you know uh when you're building a classification model to say that, okay, this is how you know that a credit card transaction is fraudulent or not. You're passing data about the size of the credit card transaction, maybe the location that the credit card transaction is happening, the all those features, all those data sets are what you would pass into the model during training, and it's going to find the line of best fit that best describes what describes a fraudulent credit card transaction. Once you have trained that, the weights and biases will be, saved in a file, and then you can save it. You pass in those new features to be able to tell you or predict whether the credit card is, whether the transaction is fraudulent or not. But because you had to train the model, that is not that is not a zero shot, right? Zero shot is a chat GPT. It has been trained on petabytes of data. Zero shot is a blip, is a BERT that we used last week, right? It has been trained on a whole lot of data, and you don't even need to do any more training. All you're doing is extracting information from the model. The next one is few shots, right? In a few shot model with a transformer model, you can now, just give it an example. It the information you're looking for, it probably already knows it, but it won't know how you want it represented, how the shape and format. So you can give it an example, right? This is an example of a dialogue between AI and human. Now I will ask you a question about this, and then the AI will be able to give you an answer that looks like those few short examples, right? A few shots is like retraining, but in few lines, in few examples, right? Now, the long shots retraining is now what is called fine tuning, model fine tuning, right? We unfortunately we would not be getting there. All these models that you are seeing there, the example model that we, showed last week, you could fine tune it. You know, the Salesforce team of they use a Cocoa data set, which has about, I think, 3 billion images, right? But if you have some images that you believe that wouldn't be contained in the data set, you could fine tune it, right? So that is those are ways you could actually leverage a transformer model. The example of the assignment that was given last week was a few shots. You are just we asked you to send an image to that model, and the model should be able to tell you a caption, of what is in the image. We were never able to do that. It was impossible problem, right? Because we're now moving from a domain of image to a domain of text. Similarly, we can move from a domain of text to a domain of image. Now we can move from a domain of text to a domain of audio. We can move from a domain of audio to text. We can move from audio to audio. We can move from image to image, right? And all these things are representation of human intelligence, right? The kind of language you speak, the words you write, the paintings you do, the infographics you put out. All these things are representative of they are representing collective human knowledge across time, right? And now a machine could read it and know that, okay, this is the information I've represented in this image or this audio or this. So it is incredibly powerful, and that is the reason why we say transformer is eating up all these other models, because what you could do with other architectures, you could still do it with transformer. Maybe a few shots, you could do it in a few shots or a zero shots, right? You could do sentiment with zero shots, for example, with a transformer model that's on a word pipeline, right? A text pipeline, NLP pipeline of transformer model. You could do it in zero shots. Sentiment, the whole sentiment analysis. Tell me whether this is positive or negative. You put a word and then it tell you positive or negative, right? That is the power of a transformer model. It will take some serious effort to do it in a classical way, but now in zero shot way you can get your answers. So if it is not possible in zero shots, it will be possible in few shots. If it is not possible in few shots, it will be possible in fine tuning, right? Which is the long shot, retraining. And this is the reason why we say transformer is sitting up the world. Very soon, a transformer model will be able to. Actually, this is the problem set we're working on at the foundation. If you're very, very interested at the after today, actually there are projects going on in the foundation right now. There are products that are being built, AI models that are being built into products as we speak, right? An interesting thing that I look forward to seeing in the next 3 to 5 years would be, a transformer that could make a movie that never existed before. You just tell it what you want to what you want to watch, right? It just tell you what you want to watch. I want to see a movie that is that's a action themed about an action movie, maybe horror and a little bit of this thing, and it writes the script and then sends it to the decoder that's able to transform that to a video, and all of that done in real time. That would be incredible. That would be incredible, right? Another interesting thing we're doing at the foundation, right, is a imagine if you've used all these apps, chatbots like Ziggy, is it for Zenith Bank, and Leo for GT Bank, Leo for UBA, I'm not sure, right? Say text, press one for account balance, press two for this thing, press three for you press 20 or you press nine, it is lost, right? Yeah, that's UBA, right? It is lost. It can't do anything because those are not really AI systems. They are deterministic codes that was written. If response equals to this, then do this and do this and do this, right? The power of AI model is that they are not deterministic, but while that may seem bad, but that's actually what made them powerful, because you could have a normal conversation and they can understand intent, understand reason, and respond logically, at least, right? So how about you have a conversation with, hey, I would like to check my account balance. Okay, what's your account number? Right? My account number is zero. 0051224455. All right. Could you, provide the authentication? Where is your uh, place of birth? And then you respond, right? And it's okay. Your account balance is $24,500, right? You cannot achieve that with classical AI models. But for you to do this with a transformer model, all you need is a transformer model that is capable of speech to text. We've had we've had speech to text and text to speech for some time, but they're not transformer models, right? We used an example of back model that is based on transformer. Look at the audio quality; it's different. It's different, right? So now imagine as someone is speaking on the other end, you are taking the voice data, the voice image, passing it to your audio to text transformer model. You're extracting the audio, passing it to your inference engine like a chat GPT, right? Telling you, okay, based on the information that we have, or based on how this thing works, okay, this is the next line of action. It calls some APIs, it does whatever it needs to do, and then it generates the textual response, converts it right back to now use the transfer model for text to audio, right? That's text to speech. Now it responds right back to the speaker at the other end, right? This is solved actually as of today. This problem is solved as of today. The only challenge is that the time lag, because it takes a couple of milliseconds, right? And it's not natural. Someone will know that okay, something is calculating, the kind of response and what to say. But it's good. Like we were never able to do that. Just think of what will happen in the next, you know, 5 to 10 years. It will be real, natural. With that pause will be gone. Yeah. So these are the real AI that is going to take people's job is the transformer guy, right? That will take people's jobs, or that will reduce. Yeah, let's just say it the way it is, take people's jobs. It will, right? Because now you don't need a 20-man support team, because you can just build a small system that will you know assist the human agent, the human customer support agent, right? So you can have the same throughput with two people. Something that used to do with 20 people, you do it effectively with two people, and that's the power of encoding information and decoding information in different modalities that humans express intelligence. That's a long one, a long-wounded answer to your question. But yes, the fact is transformer is really eating up the world, and we can't stop it. Another architecture may come up later in the future, but for now, it is what it is. Do we have more questions? I would like us to get into the real. Okay, Stephen, please go ahead.
Okay. Based on what you've told us just now, and if one wants to be an expert in this field, be as good as you, would you advise the person go through the ropes again? Why not just go study transformer and rest?
Yeah, so it will be hard for when they are saying, okay, we are using this optimizer function so that we can do this. You would not get it. You would know what's an optimizer function, right? Why are we using an optimizer function? All the AI models that will be built in the future, it may not use transformer architecture, but they will definitely have an optimizer function. They will definitely have a loss function, right? The goal is to minimize the loss as much as possible and make sure it's going down. But there has to be some ways to which one do you use and all of, so it's better to let that. That's why we went through that journey, right? You have better appreciation for what is coming, but without understanding the basics, it will be too tough. It will be too tough on you.
Actually, what I mean is, do we still have to go and learn the likes of the LSTM, the natural language processing, and
There's,
RNNs?
there's no point. There's no point. They're not as performant. So you could learn it for the sake of knowledge, but you can't. they are not 50% as performant as what we have today. You could, for the sake of just okay, where are we coming from? I do that sometimes. There are a lot of old architectures that are not relevant today, but they led us to the next big thing, right? They led us to the next big thing. Okay, this is the next thing to tweak, or this is the next thing to change in the architecture. So for you to have that context, it may be good, right? To just go through them. Does that make sense, Mr. Emmanuel?
Okay, just to address some of the points you said, ideally it would be wise for you to like really understand the nitty-gritty, understand where they are coming from, understand the architectures. Because like me, sometimes too, I will just go to like the TensorFlow websites. I go and check some of their tutorials, and I see a lot of things. Sometimes I really really go back to go and learn from the scratch. I look at the basics so that I have the fundamental knowledge so that if I'm going to start to go through those transformer models and the like, I would have a deeper knowledge because there are certain terms or certain words that you might be using that you will not understand. They're like, okay,
Yeah.
when you're talking about the GAN thing, if not for the fact that these have done some things, I understand what the generator and the discriminator is all about. And I know how some of those things work. So if I've not read, like if I've not gone to understand the basics, the nitty-gritty, I've not gone down to I had to go back to go and learn things like convolution neural network from scratch again. So that at least I can, be well grounded and understand everything. So that while you're talking, it gives me that sense of understanding. Okay, even the truth is, so the transformer model itself, if you go through the papers and see some of the things they still did, you'll find out that they still call some of those functions like your 2D convo, your 3D convo. Some of those terms are not really out. They've not phased them out though, but they modified them. So it's good you understand those basics. And I think it will help you when in terms of reading, and it will foster your knowledge and understanding very fast.
Yeah.
But I have a question to ask later. I'll ask that.
Sure, please. Mr. Steven, are you good? Can someone else go ahead?
Yes, I am. Yes, I am, man. Thank you, Emmanuel.
All right. Emmanuel, please go ahead with your question.
Okay. All right. Okay. Thank you for the privilege. And okay, what I wanted to even talk about, the question I wanted to ask was with regards to fine tuning. When you talked about the one shot, zero shot, and the few shots inference. So like the prompting, like for instance, if you want to look at the GAN architecture, or you want to do something that has to do with maybe video. I don't think there's no, okay, yeah, I think there are some transformer libraries that they've written that is related to what you can use for GAN, but you find out that what you still need to use is things like your diffusion models, stuff like that. So how do we train, like for instance, if you want to do something like text to video, how do you train those diffuser models like your stable diffusion to give you that GAN, that transformer feel? That's my question.
Okay. Yeah. So transformers and diffusers, those are two key concepts. We can argue that a diffuser is a transformer, because it has an encoder and decoder as well, right? You're going down, you're downsampling, you know, during the downsampling part, you could say that that's the encoder module of a transformer. And then the upsampling part is the decoder part, right? So yes, you could argue that a diffuser is a transformer, model, but there are, nuances to it in terms of how they are different. But question is, how do you fine tune a diffuser model, or how do you fine tune a transformer model? Sorry, could you clarify? Or how do you combine transformer and diffuser architecture?
Is a combination possible? But how do you fine tune the diffuser
Absolutely.
model? How do you reduce noise and stuff like that?
Absolutely. So most there are there are bunch of diffuser models out there. So there's no general way of, wow, my battery is low. Sorry, let me quickly plug. 1 second. All right, I'm right back. Sorry about that. Sometimes I forget that I need to charge my system. Yeah, so how do you fine tune a Diffuser model? Actually, we are going to do something together today. We're going to work on a Diffuser model together. Uh, we are going to train a Diffuser model together, right? But that's kind of like the primitive level of a Diffuser model. There are a lot of sophisticated Diffuser models out there. I showed us, some last week. You know, there's VIT, there's Bleep, there are a lot of different architectures. What is happening there is that the author of that architecture would essentially, some people will add some interesting stuff, right? Some people will, remove some layers and replace some layers, and just to test the performance of those models against some other state of the art that's known, right? So um because there isn't one diffuser architecture, there can be one generic way. So usually what you find is that the author of that model will leave an instruction for fine-tuning, right? Let's take a look at an example together. Um, so can you see my screen?
Yes.
All right. So let's take a look at one here. Mm, where am I? Okay, sorry. I'm in transformers. Let me go to diffusers. Uh, and then, okay, so here are some tasks, right? Let's see. Okay, you can actually open this in Google Colab. This is conditional image generation. Uh, okay. There is a okay pipeline. So these are the different pipelines. Let me make something clear. Last week session may be confusing because we went deep into what is inside those pipelines for text to text, right? We did text to text. We talked about every single component so that you can just understand, right? But we then talk about the pipeline function, right? The pipeline function has just encapsulated all those things for you, that you don't have to be the one defining you know the positional encoding. You are not the one defining the attention, self attention, or the maxed attention, or what kind of attention, different set of attention, or the multi-head types, right? So by simply passing the pipeline, by calling the pipeline function on the model, it knows the stages of massaging the data sets, right? Whether it's a pixel information, or word embedding, or audio array, or whatever information it is. It knows the pipeline of actually taking the data through it to extract the information, and then to be able to decode it right back. So these are some pipelines right here. Most of these things are actually for knowledge, for if you're looking to go deep, right? So here under training, you will see different types of training methods, right? This is LoRa. This is LoRa method. This is very, very popular in terms of the fact that it's parameter efficient. Dream booth. There are lots of them, right? So a simple answer to that is that there won't be a generic way of fine tuning. Most of these things will be model specific. The fine tuning a diffuser model, even though it is a diffuser model, will be model specific, right? So most of the time is to read the manual that comes with the model to find out how to do it. Usually it's pretty simple. At the end of the day, it's going to be collecting data, extracting the information in the data, and then passing it into some helper functions that helps you do it. Right. So you can study this section of uh, of the diffuser model to get better information on that. Does that help?
Yeah, sure, it does. Yeah.
All right, all right, all right, all right. Awesome. So, interestingly, a diffuser model is currently being used for audio problems. Because I said at the end of the day, it's still some sort of information you're passing through the downsampling and then the upsampling. We call it units. The model is a unit, right? Downsampling is the first part of the U, and then upsampling is the other part of the U. So you can see other interesting pipelines. This is dance diffusion. There's a music LDM. I think there's something on our notebook about some of these things. We'll take a look at them shortly. So, yep. Okay, so let's get into the main part of the day. Let's solve the assignments for last week first, and then move on from there. So last week, say use this transformer model. This is a transformer model from Salesforce. Um, so bootstrapping language image pre-training for unified vision language understanding and generation. Very, very long. At the end of the day, it's still a transformer model, right? Can you see the architecture? This is the transformer architecture. So what do you inject at the encoder layer instead of words that we used last week? It uses image, right? Image input data. And the self-attention, same self-attention, similar to what we did last week. And then a feed forward, the regular feed forward neural network, right? And then you have the image encoder. The number arrays that you would have here would represent the image, the input image, right? Now, next layer is where your question comes in, right? The word to word transformer model that we did, it will use the question, the question asked to the model will be at the encoder layer, right? And then it will start a close of start of sentence or end of sentence to start generating at the decoder layer, right? That's how it works for the word to word. But here, question: what is the dog wearing? What is the dog wearing, right? This is a bidirectional self attention and then a cross attention. They're simply just describing their architecture here. This is completely different from what we talked about last week. And this is where I was saying that there are no two transformer architecture born equal that are the same. They are the author of that architecture would have swapped some things, would have changed some things that represent the data set or the problem set that they're trying to accomplish. So this is essentially the transformer architecture for this particular, you know, this particular model, right? So here we used generative AI demo. Actually, I should remove the audio. It's no longer audio anymore, right? Let me drop this link for you to, if you want to play with it, as we're speaking here. Okay. All right. So the instruction to use it is actually there as well on the model. You can come down here and click to expand and see the instruction to use the model. This is using GPU, right? And then this is using CPU. So I have a GPU on my Google Colab. We would still the challenge with the whole GPU arrangement with the American kernel was, whether we use a credential sharing approach or how to solve it in a scalable way. We couldn't really define a way to be able to solve that in a scalable way, but it is still something that we're looking into, right? So some of the things that we'll be doing today will be tough to do on a CPU. Still get it right? You'll still be able to do it, but you can use the CPU method to test it out. So if you take the code and come here, so the Bleep processor helps us load the Bleep model, right? So we from the transformer library, we said okay, import processor and then Bleep for conditional generation, right? So we loaded the model. This is the path of the model on Hugging Face, right? We loaded the model. Usually we've used it from pre-trained a lot, right? So this is the model processor, and then this is the actual model itself, right? This is the model processor, and this is the model itself. So the processor, similarly to how we described the ways the data in the pipeline would be changed, would be padded, would be, sometimes it will add some, new vectors, sometimes it will add some new, multiply some new vectors, sometimes it will, just manipulate the, input data so that the output of the encoding is representative of the input as much as possible, but in numbers, right? So most models come with their own processor, right? So here we have the model, here we have the processor. So this is the image. We have an image here. So this is part of the image that was sent. So we asked that you should use any of these images, to get a caption of that image. Let's load the image and see. Okay, I think this is it. Yeah. So this is a building, this is a house, right? So if I come here, let me install Transmart real quick. It's the same, notebook that we've been using. I've just been adding more stuff. Okay, I think let's do this music generation as well. A transformer for music generation. I think I just added that not too long as well. We've done this back model. We've done this back model. We've done this Facebook MMS. Okay, there's a pop to piano. I didn't complete that code. I didn't complete that code for pop to piano. You could create music, from other music essentially. Speech to text. Speech to text. We'll probably just quickly run through that as well. So this is where we are. This is where we are. Let me. All right. So now, if I run this, it will simply, so I have CUDA running right now. I have CUDA, but if you don't have CUDA, try to run this part of the code, this CPU one. The difference is simply between your this CPU one and the one that I'm running is that, to there is this part, there is this part, you know, on the model. I'm piping it to CUDA, which is, see, I'm on V100 right now. Okay. My computer is even low, actually. So I'm V100, which has about, about 40 gig of GPU, right? But the difference is just to remove this to CUDA. I have to CUDA here as well. I have to CUDA here as well, right? I'm piping it to float 16 to increase the speed of inference, right? Because float 32 will be bigger, will be double of that. So you could see there's no to CUDA here. Model is just straight up, right? There's no to CUDA here. That's the difference, right? And then there's no to CUDA here. So if you're running this on your regular notebook without GPU access, just try to remove all these to CUDA, to CUDA, to CUDA, or just run the CPU version of the code right there. You'll be good to go, right? But just this, for the sake of speed, I have to pipe it to CUDA. So I sent in this image, this particular image right here. yeah, that's the image URL. So image.open, this is a standard image Python library. We pass in the image URL that we define, the variable. This is a string, right? From Dr. Tulu's class. Image URL is a string. We load the URL using request.get, and then we use it to load the URL. You know, we capture the raw data, the binary data, and then called image.open on it, and then convert to RGB because we wanted three channels, right? RGB. So always, this is okay. So I think it was Mr. Emmanuel Odell mentioned something about prompting. This thing, right? You're looking at here is prompting. We are now prompting the model because if you don't prompt it, it will just probably start with the end of sentence or start of sentence. So, but we wanted to, start. We are seeding the start of the sentence such that the beginning part of the where is it? The beginning part of the decoder layer, you know, sorry, the answer, right? The beginning part of the answer will now have it will, because it is auto regressive, right? So it will be the a photography of, and then it will now try to predict the next word after a photography of, right? Essentially explaining at the end of the day, it will now be like an explanation of what is in the image. So this is the text, right? So this is the processor we imported from here. So we have Blip processor, we imported the image. So this is the processor right here. And now we are passing the image to the processor. And then the text, right, that we are seeding the model with. Again, I'm piping it to CUDA. So just for speed, right? Just for speed. And then I said model the generate, passing all the input, right? So this is our output. So this is what we are showing. And at the end of the day, it says, what did it say? A photography of a two-story building, right? In terms of counting the ground floor or not. But essentially, this is a two-story building with the ground floor, right? So let's put in the next image. Let's put in the so if you need any application that needs to use or maybe it needs to explain, this is actually how Facebook solved the hate speech problem. They created a model like this because they had about at one point 10,000 staff members looking at all texts and images and content that people are posting randomly to ban them, to take those content down, especially during election and all those stuff, right? So this is how Facebook solved that problem. They just, implemented a transformer model that is able to, explain what is in an image. If it is, if the model cannot tell the factual status of that information, it will just flag it for someone to take a look at it. But imagine a platform that is receiving millions of images per minute or per day. I don't know, maybe per hour. It will be an impossible task. So their approach of using human beings didn't work until they used this approach. So you could, essentially just copy this code. You have there are several applications for this kind of thing, essentially, right? But that one example is just how Facebook deployed this for quickly acting when people post, wrong information, but in image. There's a version of this as well for text as well. So let's copy the next image and see. I'm just taking one randomly. Okay. This is like two wolves or three or four, right? Actually, there are many. One, two, three, four, five, six, seven. That's the number of wolves there. It's pretty hard to see. So I would comment this. So you could just, once you copy this notebook, you can simply just uncomment it and run, right? I would give it the same uh, the same name, and then run the code. Let's see what caption it comes up with. Okay. Okay. So it says a photography of a painting of three wolves in a field with a full moon. Wolf painting of three wolves on a hill. The guy could only see three wolves, actually. These guys, you could see only the three here, but there are actually some other wolves right there. But I mean, this is not bad. This is not bad at all. Let's take another one. I think this is the real estate one that I just did. Let me confirm. Yeah. Let me pick up another one. All right. So let's check this out. I think it should already be there. Okay, yeah. This is it. So let me uncomment this and run it again. So without using GPU, it will be actually slower than this. This is one of the problems of, yeah. So it's a photography of a black iPhone with a white screen and a white background. iPhone 4G. So second one, iPhone 4G with one black background, right? So you could just test out the rest, and you're good to go in your application, especially if you check. This was trained on Cocoa dataset. If you want to check the Cocoa dataset, I think it should be this one. Should be this one, right? It contains 663 million images, right? So there's a high chance whatever it is that you're looking for would be contained in the training, right? And looking at the data set, this is the image that was fed into the encoder. This is the text that was, which is the middle layer, right? And then this is the caption. So let's take a look at this, for example. This is a, check it out. It looks like my network is coughing a bit. Can you still hear me? Okay, thank you. All right, I know what's wrong with my network. It's not loading this image. Okay, this is the image. This is the image. And if you look at the data set, it says Grunge last Skyline. No, 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 there's no way. Okay, the American flag and the city skyline. Really? Where's the city? Oh, I see. The American flag and the city skyline. So, see, during training of this model, without you having to specify it, the the model will be able to essentially identify this information, this context, right, with this photo, with the pixel information in the photo, right, such that if you send in a new image, right, that's totally different from what it has seen, based on the information it knows, what American flag looks like. I'm very sure there will be other images about American flag. There will be other images about skyline. It will be able to connect the dots about. This is essentially how humans learn as well, right? You know what skyline is. You know what American flag is, right? So if I ask you for American flag with something else, you will be able to. You may not be able to draw it because of we're not all that creative as humans, right? Not all of us are creative, but essentially you would have an understanding of what it means. So this is This is how this was trained, right? The caption together with the URL, and allows you to now send any other image, and it will be able to tell you what is in that image, right? So this is what a Cocoa data set looks like, and it contains 663 million images. So you can play with this, take a picture, with your phone, and then take a picture with your phone and put it online. Uh, that can be loaded, and then let this guy, you know, tell you the caption in that image. Does it matter? Does it matter relearn from new image it's fed? It's not during inference, it's not learning. It is actually, it is it is essentially looking up from its knowledge base. Let me use that term, right? It is looking up from, okay, because it has, there are certain things it knows, and it could map those things that it knows to some input data that it was trained with. Remember when we said, when we're doing that, we're starting diffusion. I think that should be about 3 weeks ago. That you train the model with a concept called avocado, and then you train the model also with a concept called chair. But now you can ask the model for a chair that looks like an avocado, and it will be able to create an image that fits that description, because it knows what a chair looks like, it knows what an avocado looks like. So up to what is happening at the processor level is essentially just vector manipulation, whether it is addition, I don't know, or multiplication, or it's essentially just manipulating the vector that semantically represents avocado, and then manipulating the vector that semantically represents chair, to now combine those two ideas together to give you what you're looking for, right? So similarly, this guy, having been trained with a whole lot of concepts like American flag, indigenous peoples, history of the United States, I don't know, let's see what that image looks like. Oh, it is behind, this image is behind, oh, okay, an indigenous peoples, history of the United States. Okay, that's a book. That's a book, right? So it knows all these, the cover to Call of Duty Modern Warfare, two pursuits, and so it has an understanding of existing caption with images, right? And then it has the, based on the training, right? It will have the representation, vector representation of this information, right? And by the time you're asking it to generate um, a caption of a new image, it will be able to look up from, okay, what it knows. This looks like, uh, remember the similarity, what do we call it? Cosine similarity function that we did last week, right? So it can actually know, okay, these ideas are similar, right? By just looking at the vector, it will be like, okay, these ideas are similar. This is talking about ports. This is talking about spoon, right? Spoon is so close to ports in the vector space, whether it's 5 dimensional vector space or 10 dimensional vector space. And that is actually where creativity of an AI model comes in. That's what makes them look like they're creative, right? Because there are imaginary, it's imaginary because humans cannot imagine information beyond 3 dimensions, right? We can't what does that look like? We can imagine that, but the mathematics is still accurate by manipulating the vector, by doing things like the vector similarities, by doing all those things. You can actually get to understand what you're looking for, and be able to still create this vector to create the image, essentially. So it's not uh at inference time, is essentially not retraining, right? It's not retraining, or it's not trying to actually relearn anything. But yes, you can retrain these models. I wish we would have enough time. We don't want to make this thing so long, excessively long. What I can do is to share a notebook to retrain some of these deficient models or transformer models. There are notebooks like that you can, out there that you can manipulate. You have your own images, maybe after checking the Google data set, you see that, okay, there's no image of a black woman in that image. And then you want this model to be able to understand, a black woman smiling, what it looks like, or a black woman riding a horse, what it looks like. So you have those images, and then you want to fine tune that. That is also possible. I could share a notebook for that, to allow you to do that. All right. So yeah, so play with this. Just take a picture, put it online, and then to use the link to put a link here, and then see if it's able to give you a very good caption, right? So now imagine what is possible if with what you can do with this text. You can pass this text to another processor, like a word processor, like ChatGPT kind of model. Oh, requires access. I will make it open. How do I do that? I Let me put it on my GitHub. Uh, how do I do it? I don't used to. You know what? I'll check this later. I'll check the access thing later. Okay, so real quick, let's do a transformer model for speech, right? So here is the code for that, a transformer model for speech. So here for this, we're using an OpenAI model. This was when OpenAI was open. Someone last week said
Sorry,
OpenAI should have a
Tezro,
call.
can you increase the font size? Please, the font size of the text is too small.
Oh, I see. Is it better?
Yeah, it's cool. It's cool.
Okay. All right. All right. Don't worry. I'll check the access, Samuel. I'll check the access and resolve that shortly. Let's just go on. All right. So again, from Transformer, everything OpenAI has done till date is due to the breakthrough on transformer architecture, right? All their vision thing that they released recently, they're stealing from the open community, not contributing back and all of that, right? But I mean, it's okay, right? So their text to speech is again based on transformer architecture. So here is the module within the transformer architecture that helps you to load that model. We're specifying English right here, tiny, because they have a bunch of variation of this model in different languages and different sizes. But just for the sake of demo, we are loading the English model. If you want to check that out, you can just copy all of these and punch that right in here. Yep. So this is what we're working on. Whisper is a pre-trained model for automatic speech recognition. It was trained on 680,000 hours of labeled data. Whisper models demonstrate strong ability to generalize many, blah blah blah. If you want to check that out and read the model card to get, so they talk about their processor. So this is a very interesting thing. Again, with what I was saying earlier, that no two transformer models are the same. They're not born equal. You need to follow the manual. You need to follow the manual that comes with that transformer architecture, from, described by the author, right? So here we've not used anything like Whisper processor, but here the guys created a Whisper processor to be able to handle their pipeline, or like all those pipeline that we did for word to word. There's a pipeline that has to be used for this model, right? So that's essentially what makes it powerful. It makes it not easy to abstract, but that on its own is what gives it power. You can abstract it generally, But again, it's a transformer model based on the architecture, but the details of what happens inside those layers could be different, and that's what those people, what they are abstracting in their processors. Right. So we imported the auto processor and then the whisper for conditional generation, and we loaded the processor for the model, and then we use this module to load the model itself, right? Again, using the from pre-train. If anything at all, the from pre-train should be very familiar now, right? So we're loading the weights from the pre-trained model. So it's going to load the weight from the public directory. So here we haven't touched on this load dataset function before. It's a function that comes with it comes in datasets. PyTorch has dataset module, and Transformer has dataset module as well. But this is the dataset module for transformer, organ phase transformer, right? All you're doing here is essentially passing, because anybody can create open source data. All those open source data being used to train these models, right, could be created by anyone. So you could load this model programmatically. And for example, if you go here, you'll be able to play. If you go to that link, you'll be able to play those data sets. It's an audio data set with 673 rows. And since you guys, all right, so you guys can play with the data set. Um, so what we're trying to do is that we are trying to use this data set to, transcribe to words. One thing I could do instead is to upload data to my directory instead of using the load data sets, right? In a real practical scenario, an example of a phone call thing, you want to understand what is being said, by the other guy at the other end of the phone. It will be, it will follow a process of you probably saving that phone data stream to file, and then passing it to the processor. So this is the processor. We have a processor here, right? Auto processor from pre-train. We pass the processor for the pre-train, right? Here is the processor. Now say, hey, this is the processor, and then we are passing the data. We are passing the data of the audio array. Here we're saying the second row here. Here. This is the one. So if I change it to 0, I'm essentially saying that, okay, load the audio file for the first row inside that data set. Essentially, that's what I'm saying. And then we pass in the inputs. We pass in the inputs to the model to generate, and then the model is able to help us generate a transcription, right? Can data sets work on by different teams or individually be combined to? Absolutely. Most of these data sets are, open source. They either have Apache license, or some other licenses that allows you to be able to edit it, right? So you could use them, you could modify them, you could manipulate them, right? But for the most part, changing the data sets might not be what you want. What you want is transfer learning. So here, for example, after loading this model, whisper for condition generation dot from, this is the model weight, the entire model weight. I could retrain the model, from this variable model right here, instead of having to go and find all the data sets. Imagine the terabytes of data set that was used to train this guy. I don't know, 600 and what? They said they use 600 and something thousand audio data set. That's like possibly terabytes of data. I don't want to go find that data, but I just want to fine tune it based on my own data, right? So it is better for you to do a transfer learning than training from the data of the original author. So transfer learning will carry all the information of what the model has learned over to your own information and then add the added, information from your own data sets, right? So don't worry, I will write a notebook for how to do a transfer learning. It's pretty easy. In 5 lines of code, you will do a transfer learning. Import your own data sets, your own images, your own audio, your own files, bring it in and then use it to fine tune the model. That's essentially, what transfer learning is. Can different teams work on retraining data in order to? Absolutely, absolutely, absolutely. That's the beauty of transformer model at the end of the day. The transfer learning makes it really, really effective. Yeah. So in a case whereby you want the you're interested in all the information that the model has learned, maybe about the general world, but you still want to let the model learn some specific things about a particular niche area, and you have the data set organized for that, you could easily just use that to train the model, right? So the reason why I'm doing this is essentially that because I don't want to upload a file. I don't want to upload a file, an audio file here because it will be forgotten, after some time. So if I've not no module name dataset. 1 second. I think I installed dataset somewhere and I need to bring it up. Okay, sorry. I need to take this up. So that once you run it right up here, you'll be good to go. So let me run this again. Oh, this issue is starting again. I've experienced this issue before. I don't know how I solved it. I think I may have to refresh this entire thing. So I experienced it one time that after installing transformer, and I tried to install it again. This UT8. Oh God, UTF8 locale is required, but I'm on UTF8 right now. Okay, you know what? I don't really understand the problem actually, but I was able to resolve it somehow the other day. Why it complains of the? Okay, you know what? Usually when this happens, what I do is to restart the runtime. Where is restart runtime? The runtime is corrupt. Runtime, change runtime. Uh, Let me change to another runtime. It will restart it, and then I'll be able to run this again. I think that's how I solved the problem the other time. Yeah, there are some tiny issues here and there with. Yeah, thanks. All right. Okay, it's all good now. So I'm importing the dataset that allows me to load datasets from public directories and open directories. So this will allow us to load. This will allow us to load. Yep, this particular dataset. So I don't have to upload a dataset for these. For these, I don't have to upload an audio for this essentially. So yeah, when you're playing with this, so just change this 102 up to 73. Change this between 0 and 72 to get the transcription. Right? You can come here, type this to the dataset part to listen to it, and then change this between 0 and 72 to see how well it's able to transcribe the audio, right? Okay, so this is installed. This is installed. Uh, so I'll just quickly run this and move on to the next one. So there are a bunch of demo on this generative AI demo notebook, a bunch of them. Right, so it's loading the model and it's trying to run it through the model. The model is pretty light, so in 151, 151 MB. Right. All right. I would like to move on quickly to diffusion code so that we can save some time. We'll likely overshoot 7 p.m. What by a few minutes. Okay. All right. So this is the text. Mr. Quiller is the apostle of the middle classes, and we are glad to welcome his gospel. Let's see. Right. Can you see? Mr. Mr. Quilter. Oh, it might not. I don't think it got the spelling of Quilter right. Mr. Oh, it got it right. Okay. So Mr. Quilter is the apostle of the middle classes, and I think my network isn't trying to be my friend today. Okay. All right. So Mr. Quilter. So sorry, guys. My internet connection is really failing me. Um, Sorry about the interruption. Can you hear me now?
Yes.
All right. Okay. So I was just saying that you can play with this. They change it between 0 and 73. You will see what it will come up with as the transcription of the audio, right? So the application of this is massive in terms of like building a system that can respond real time to audio, right? Uh, okay, see, it's obviously unnecessary. The, the transcription is what's in this code. It's obviously unnecessary for us to point out in the audio text. So just play with this and This is a text to speech transformer created by OpenAI. So they didn't take back this model when they became closed AI. So they left it for us. Thanks to OpenAI. I wish they left the ChatGPT model as well open. That would have been great. So this is another fun one for you to check out. Okay, we've checked out Facebook, checked out the back, mess with it. So let's play with this. This is a model, so you can use to generate music, right? So following the same thing from pre-trained, you have your model, you have your processor. So the processor thing really gets the job done. You don't have to cram anything in terms of the pipeline. You don't have to, the processor that comes with the model knows how to process the data, right? So now we call the processor, we pass in the text, and then we say generate. All of this processor gives us the input. We pass the input to the model to generate, right? And then we should have something that sounds like a music, right? At the end of the day, if everything goes right. So you could play with this as well. Change the text here to see what it comes up with. So let's quickly see. So and I did this one this way for some reasons. Let's let it finish. So everything that this model does, they generate some audio arrays. Is the audio array? See these audio values here. That is the sound. These audio values. That's the sound. So I now saved it to file just to demonstrate that okay, you can actually convert the audio values. You'll see the value once it's done. It's 1.2, comma blah blah blah, comma whatever, right? Imagine you just change one of the audio array by a little bit. You will be changing the information contained within that audio, essentially, right? Even though it is synthetic, but it has found a way to, kind of like say, okay, this is, the encoded information for this particular audio information, right? So by passing the audio values as data, I can use a function, a module scipy. I think we installed it up there to write it to file as a wave file. You can use it to write it to file, right? We're writing the synthetic file, and then this audio value will print it for us. Why is this so slow? Oh, so, okay. I think the model is quite big. It's about 2.33 gig. The model is quite big. Okay, so it should be fast from here, right? So it's generating model to generate. It's model this model to generate, and then passing in the input that we have in here. So it's generating the audio. You may not be able to hear the audio say anything because of this issue with the platform we're using. But I'll try to download the audio and share it on the group like I did the other time. So if you want to check out the architecture of the model so that you can pre-train, fine tune it, or do whatever you want with it, right? Check the author of the model. It's from Facebook, and then Music Gen is a text-to-music model capable of generating high-quality music samples, conditioned on text descriptions or audio prompts, right? Blah 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 blah. If you're interested, okay, they even attached some collabs for you to test out, right? Okay. So I think I'm on T4 now, and T4 isn't as good as the other one, so it's quite slower. It's slower than the corrupted runtime. All right, so it's done. So right here is the audio array. This is the audio array, right? That is now converted, right? So I'm now saying that see that audio array, the numpy convert it to audio. This there's an audio function from IPython display. I imported audio function. That's the function that creates this UI that you're seeing, right? This is the function, this is the module that creates this UI. So I pass in the audio values from here, something that we got from here, from the model that generates, right? I passed it to the audio, imported audio module, and then it gives us this. I can download. Why can't I download? You guys you could not hear it, right? Did you hear anything?
We
No,
can't hear
sir.
anything.
Okay. Don't worry. By the time you get access to this document, this notebook, you will be able to play with it. I could not download. I don't know why I could not download this one. I don't know why. I should see download here, but yeah. So we essentially converted the audio values. This, nonsense number is a whole lot of numbers actually, right? For 5 second music, it's a whole lot. So that's the audio array that we converted to, to audio, and it sounded like real music. If you check our this thing, you'll see oh, fantastic, I can download this. Thank God I saved it. So this is the line of code that saved it. I saved it as a wave file, and I can download it right here. I saved it on my Google Colab, and I will simply share it right here so you guys could check it out. All right, this is it. So you guys should play it. All right. Fantastic. Thank God I added that line of code to save it. I think I had the same issue. That's why I added it. So you can do whatever you want with that synthetic data, and your imagination is the limit, right? So there are lots of other demo that I've added. I always put more stuff here. I think I've even removed some. There is one I was working on that could convert a song and change the musicals, right? Generative AI is really powerful, and this is what makes AI scary, that it's making everybody to say, you know what, let us stop AI for 3 months because the pace it's moving is too fast. We can catch up on all of those things, right? Because it is so hard for you to differentiate between what is real and what is synthetic nowadays, because the AIs are so good that they can create fake data that looks so real. Facebook launched some interesting features on their platform using celebrity, but they gave them a different name. And those guys are fake, right? They are just, some number arrays compiled to, audios, or compiled to images in different frames, or compiled to, do you get, right? And it is so hard for you to distinguish between what is fake and what is not fake, actually, right? So that's one of the reasons why it's scary. But this has massive application in industry. There's a lot of ways you could apply this to actually make create value and make a lot of people's lives better. And one interesting research area at the foundation that we are interested in, which we are going to be working on over the next couple of months, is building a classification model to actually tell. There are some of these classification models that can tell, but they are not very good yet, right? Because the AI is kind of like beyond the curve. It's at the edge of the curve, right? So now you need a classification model that will be able to tell you that this is AI generated video, or this is actually real video, or this is AI generated music, or this is real music, right? For safety, this model will be used for AI safety, and helpful in curtailing bad behaviors that could come with generative AI, essentially. So I will keep adding more stuff to this demo sheet, generative AI demos. It started with audio, but it's no longer audio anymore, right? So once I add any update after this class, today is the last class, obviously, right? So I will just drop a note so that you guys can check it out. Um, so real quick, lastly, let's run through diffusion model. I won't be able to explain the code because it's too long. I won't be able to explain the code because it's too long, right? And we have 15 minutes. Try to spend time, you know, the code is pretty easy to understand. Try to spend time on it. So I split the code into into different components. The first component is the utilities, right? This is part of what Emmanuel Odo was talking about. This is diffusion model. We are building diffusion model from the scratch up, from the ground up. And I attached some credit, some credit from the other guys that made it easy to be able to, stitch this together, right? So you could check out their repo and, play with it as well. So this is from Mini Diffusion, and the GitHub is attached as well, right? So we are essentially building the diffusion model from the scratch up, from the ground up, and you know, uh, this is the code block that instantiates the class, and it imports the neural network module from Touch, right? NN. That's where this is coming from. NN.module is coming from NN right here, right? And then we built some sequential, you know, yeah, this is the very thing that Dr. Tulu took you through some 5 weeks ago, right? Built some first layer, and then we have the second layer, right? Uh, it is your regular convolutional neural network, right? Just like that note described. We have a unit. We are building a unit using convolutional neural network. So the convolutional neural network is a building block of constructing a unit, essentially, right? That's what we're saying here. So this is the feed forward function, right? And get out of channel method to get the number of output channels for this block, method to set the number of output channel for this block, right? It's kind of like a little bit augmented, right? This is where we're constructing the part of the unit, right? That's the second layer of the unit. So here's where we're constructing it. It's a different class. And then here is where we're constructing the unit down. This is a class constructing the unit down, right? So with that, now here is the embed. This is very, very key. The embed part, because a unit is taking an image, adding noise to it. Right? If you not forget the class from 3 weeks ago, right? It's adding noise to it, and then it wants to be able to denoise. This is DDPM, denoising diffusion probabilistic model, right? There are other methodologies, but this is the one that we spoke about at length, right? So it adds noise to it, and then it wants to be able to predict the noise added at the upsampling so that it can get the original image right back. So that it can always, so that during inference time in the future, when you send it a word, it can start from noise and get to a real image. That's the idea of this architecture, DDPM, right? So the embed adds the input embedding as a linear layer to the neural network. We're using GELU is of rectified linear units, or is um what's G standing for again? It's eluding me. GELU activation function. Yeah, yeah. Gaussian linear unit, right? This is the activation function we're using right here, and then we are passing the embedded the embeddings. Embeddings is just the vector form of the text. So if you say that, okay, this is a cow running on, so the cow running on the field, right, would be generated here and passed to the neural network. the layer of the neural network. That's what we're doing right here. And so the class has some helper methods. Unfortunately, I won't be able to spend so much time to explain the code in detail. It's quite huge because we're simply trying to build a diffusion function from the ground up. But if you come here and run it, right? If you run it, let me fold this. And then here we're setting our hyperparameter, the time step 500 equal, the beta, and then here I will be using GPU. Yeah, thanks, Doctor. The Gaussian error linear unit, yes. Right. So running this, so I'll quickly create a directory. Okay, I still have it. Wait. So fantastic. This is good. So I have a directory. I created this directory by myself by simply saying new folder and then calling it weights, because that's the directory I used here. I have a directory called weights. I want to show you how how a pre-trained model. This is a PyTorch pre-trained model. Model. We want to load it and see how the diffusion model is trained. Let me just run through all of this. The stuff is properly commented, so you should be able to understand quite a bit. So I just loaded the model, right? The model is loaded. So now, fantastic. So this is what is happening. This is where it starts from. It starts from pure noise. Let me pause it. So this is a pre-trained model, by the way. This is a pre-trained model. So the data set is inside here. Is inside our African AI Foundation GitHub. This is the pre-trained model. This is the pre-trained model that that was based on Sprite. So this is the data, the Sprite. The data is Sprite. Oh, I thought I uploaded it. Here is the data set. Let me show you right here. Right, this is the data set. Sprite images. It's a 68 MB file. So we converted all the images into NumPy file, a NumPy file, right? So these are so we started from there, and our goal is to be able to say that show me picture of where was I? Okay, so this is training code. Okay, so our goal is to be able to say that, to say something in the label. Here is the file for the label, and then here is the file for the image, right? Our goal is to be able to say that something about the image and reads it. But right here, you can see how it starts from pure noise, right? So this is how it looks like, Gaussian noise, right? And then it will time step it it further, denoise it further, denoise it further, denoise it further, until you start to see the images, right? So that is how diffusion model. They start from this during training time. They start from pure image. They add noise to it, and the model attempts to convert those noise to the original data set. Because during you always start from pure noise and starts removing the noise to get the original data. So that's just what this is trying to show, right? Pure noise to pure data, right? So it's able to go back to the data from pure noise. So a very interesting part that this is trying to show here, it says demonstrate incorrect sampling. Hey, my English don't accident. This is an incorrect sampling. All right. So this is an incorrect sampling. Of there is a part of the denoising process that for example, this is the pure noise. Uh, the At first step, it denoises it a bit. you may think the next thing to do is to take this particular image and then denoise it from there. But what the researchers of this architecture found was that without adding noise back, the image that it creates is of poor quality, right? So it has taken off some noise, right? But it adds a little bit, tiny little bit, smaller than what it has removed earlier, right? So that the noise, because it's denoising it in a random way, right? So you could have the angle of the picture and the noise is not evenly distributed anymore, right? So what I found is that, by distributing noise over the pixels again randomly, it improves the picture quality that it's able to create, right? So at each step, it's removing more noise and adding a little bit of noise again. It will remove more noise and add a little bit of additional noise, a little bit less than what was removed, right? Such that the progressive sequence of noise removal will be moving forward, right? So if you don't add that little bit of noise after removing so much noise, this is what you get. This is what this particular block of code is trying to show, right? So you start from pure noise, but you get a first step. You're not adding more noise. What you get is this, which isn't looking like this in any way. Which isn't looking like this, right? So by you removing so much noise, but adding more noise, adding a little bit more noise, so that the image is like you are putting powder on it, right? You're spreading a little bit of powder on it. It is the powder that you're on the image that allows it to, efficiently scrape it further and denoise it further, right? So without more noise, after removing the noise, you don't get a good image. That's what this is essentially trying to show. But by adding more noise, by adding a little bit more noise after removing noise at each step, you are able to create sharper images, right? Right. So can you see? It is randomly adding more noise. But if you look at this, as you're going step by step, it's not adding any noise. See, it's not adding any noise. Can you see? It's not adding any noise. But if you take look at this sample, right? Each step is adding a varied amount of random noise. And steadily you could see that it's getting clearer. Even as it's getting clearer, it's still adding some small amount of noise, right? Until you have your sprite images back containing the data set. Until you have the sprite images containing the data set, right? So this is an example that we did based on pre-trained model. We just loaded a model, we created a weight file, and then we imported a model, and then we are able to run this code. But here is the code to actually run, to train, you know, to train by yourself. So I had to do this before the class started, but you can play with it as well. I've corrected an error that happened last week. It took it took even with GPU, it took how long? Okay, quite fast. But that's because of GPU. It should take you about 3 hours to train with CPU, right? It was quite fast with GPU. So I was saving the model at each weight. So model zero. So if you look at this, oh, okay, it's gone. It's gone. So I may have to run it again. That's the problem. If you save files on the local file storage on your Google Colab, it goes after your runtime goes, right? It disappears after your runtime disappears. So essentially the same helper function with the other one. We constructed our unit using convolutional neural network. That's what's happening here. And then we are now training. We now want to train. We imported all the modules that we need for training, right? We imported them here. Okay. So Yeah, we constructed a unit downsampling. We constructed the embedding layer, embed function. This is where we are adding text to the image, right? So for example, in this data set that you're seeing, this is where the text comes in, right? The American flag and the city skyline. So the embedding for this, the numerical embedding for this is what is added to the to that right here. So there's a time embedding and then there's a context embedding. The context embedding is the text that comes to the data set, and then the time embedding, yeah, the time embedding is a time step where it is in the time step, right? So yeah, there's a whole lot going on, a whole lot of things going on in this code actually, right? Unfortunately, I won't be able to, spend a lot of time to explain. So right here, I will simply just create. I could use the root folder. I could use the root folder, but to just keep things organized. Wait. So I'm storing the models in a wait file, in a wait directory. I'm storing the models in a wait directory, and I'm constructing the denoising schedule, right? So you may want to read about the DDPM denoising schedule. This is the schedule that we've just created here, right? And then we constructed our neural network model based on the class that we created up there. And then now we need to import our data, custom data set. This custom data set is a function from Touch, I believe. Yeah, sorry. This custom data set is leveraging Touch data set, but we defined it here. I don't want to take our time so much today, right? Custom data set. Here's where we defined it. Custom data set, right? Where we're loading the data set from NumPy. So we have data set for sprite, which is the real image, and then the label, what is containing the image, right? So this is the custom data set class right here. So we load the custom data set. I don't think I have that here. Let me quickly upload the data set. Let me upload it. So this is the image and this is the label. Right, this is the label and this is the image. So let me upload that. So we're trying to train a diffusion model from scratch, right? Without, of course, it is not meaningful, not really meaningful because these are sprite images like used in games. It doesn't contain as much data set as what is contained in the Cocoa data set. But this is just to show us that okay, the process is to downsample by adding noise and upsample by removing noise. This may take some time. While this is uploading, let's take questions. Don't worry, you will have access to all these notebooks. You will have access to all these notebooks. You should clone them and copy them and mess with it and see what you can get. See what you can do. It's properly labeled. It's properly commented so that you can know what is going on at each point of the code. So this is us trying to build our own blip kind of model, our own Salesforce blip model. We were supposed to do this last week, but I ran into some issues. So, wow, trying to demo this.
Hello, Mr. Israel. Hello.
Hello, hello, Mr. Emmanuel.
Okay. Okay, quick one. I'll say with regards to what you just demoed, I was going through, I saw something similar to this on the Keras documentation. And I
Okay,
tried using it. So, okay, I went back to, no, on TensorFlow, rather, on TensorFlow. So they were using this mixed precision computation float 16 to reduce, I think,
wait,
uh, for the processor of,
wait,
to minimize I think the process time or something. But eventually the
That's it.
thing crashed on my lab. I wasn't even
Yeah,
able to do that stuff again.
yeah. So it takes a whole lot of time, even on GPU. I'm on GPU right now. I'm on T4 GPU right now. It takes a whole lot of time to train the diffusion model actually. So I would not recommend. I remember a few people were interested in running it on their local system. I don't recommend doing things like this on your local system. I just use a Google Colab. Google, with a fairly good internet connection, you can work on a Google Colab because it is more graceful and more generous. Uh, with the free version of Google Colab, you have 70 gig of disk and about 16 gig of RAM to play with, right? 16 gig of RAM on Google Colab, like that's generous. So if you now want to add additional, oomph, add additional nitro, you can just pay for additional resource. So I think this cost me $10 for 100 units. This cost me $10, and I've almost finished it. Right? I think I have 3 units left right now. I hope it will be able to finish this exercise. Right. So I recommend you should use Google Colab. You don't use your system because it is actually resource hungry. It is resource hungry. So this code will work with CPU, just that your Google Colab should not sleep. Because if your Google Colab sleeps, it will disconnect from the session. If it will disconnect from the session, and you have to start the process all over again. So it will work fine on CPU, it will just be slow, right? On CPU, I think it was about 2 hours for training. It took about 2 hours to train. But on GPU, it was about 5 minutes, thereabout, about 5 minutes. So try to try to use Google Colab. If you can afford the GPU, try to use it. We would still come through on the community access for Google Colab that we promised, right? This is the reason why we had to push this to the tail end, because we could not find an elegant way of doing it, because all the ways that we identified that we could give access to this Google Colab with GPU, it came with vulnerability risk and security risk to the network at the American corner. And like giving people access to RDP. RDP has a lot of vulnerabilities alone, not let alone without giving people access for timeshare, or doing people giving people credentials to log in on Google. We couldn't find a very smooth, risk-free way to do that. That's why we've not, come through on that. But we are still you know, going to do that so that you can at least experience GPU without paying for it, right? But my general recommendation is for you to use Google Colab, and if you can afford it, pay for GPU. Yeah, that is actually with floating point 16. If it was floating point 32, Emmanuel, it would have been your system would have probably caught fire.
I'm
Your
saying
system
it
crashed.
crashed on Google Colab. It wasn't even on my system. It was on Colab. I was trying it on Colab, not even on my system.
Oh, it crashed on Collab. Oh, I see. Okay. What was the size? What were you doing? Could you describe what you were doing? You were training a
Just
diffusion
following
model,
it.
right?
Yes, I was just following the tutorial on TensorFlow with regards to the
Yeah.
diffusion
So there's
model.
a limit. There's a limit to the free version of Google Colab as well, actually. There's a limit. It's 16 gig RAM. And, for example, by the time you've loaded all these things into memory and then you're running them in iterations, like 500 iterations and all those things, the 16 gig RAM gets used up really quickly, right? So I would not be surprised that that happened. I would not be surprised that that happened. If you have about $10, I think you should be able to get up to 100 compute units. Google Colab compute units. I think I paid $10. Yeah, I paid $10 for 100 computes. and I've been using this for over a month, even for my other projects, right? So it's pretty cheap. It's they are crashing down the price to make the compute accessible as well. And with this compute, this is the pay as you go version, right? I always like to do pay as you go. I don't like commitment, with all these guys, right? So I like to do pay as you go because of the flexibility. I'm able to switch between different GPU types, right? I'm able to switch between different GPU types and do different things. Um, for example, I could change from A100. A100 is pretty hard to get. A100 is pretty hard to get, but a V100 is good enough, right? A V100 is good enough. T4, depending on what you're doing, it should work fine as well. All right. Any more questions? All right. Okay. So this guy, I think my internet is not that great. It took some time to upload the data. So this is where we were. We were uploading the data so that we can train. So the data set contained 890 89,400 images that are 16 by 16, right? 89,400 images. They are 16 height and 16 width, and they have three color channels, right? And of course, the labels, each image one, we have its own label, image two, we have its own label, similar to how, image, we have image and label, image, label, image, label, right? That's what's happening here, right? Um, so the guy has just finally been fully uploaded. You can see all this data. You can find all these data sets here, right? This is the label. This is the label. This is the one for. I think the upload for the data itself, the image data itself, did not finish. I'll check. I tried to upload it. I'll check. All right. So now that we have uploaded the data, we can now load the data set. Oh, sorry. I think I misspelled the name here. Rename the file. There's no one in it. All right, fantastic. So we load that. And then this is the guy to add just a bit of noise level. This is the upper function to perturb the image. Just add sprinkle small noise, sprinkle additional noise on the image that has just been denoised a bit, right? You've removed so much noise, but so that you can have an efficiently generated image, clear image. You have to sprinkle a little bit more noise on the 16 by 16 pixel across, right? And then it denoises it again and then sprinkle a little bit. So this is the function, helper function that does that. And now we get into the training, right? So this is where it may take some time. T4, let me check T4. Okay, not that bad. All right. T4 GPU spec. Okay, so that's 16 gig. It's not that strong. Okay. About 5 gigahertz. Not bad. I should have changed it to V100, but our V100 was corrupt earlier. V100 spec. So a V100 has okay 16 gig as well. That's interesting. So 16 gig. It looks like T4 is more powerful than V100. I thought it's the opposite. I used to think it's the opposite because V1 T4 was 5 gigahertz and V100 is 1.3 gigahertz. Okay. All right. So if you try this on CPU, it will be much, much, much more slower, right? But now, so we have the see this is the uh model for the first iteration, right? It's saved to the wait. Can you see? This is the model. We're saving it. This is the code that is doing that. So at every divide, this is saying the epoch modulus 4. This is the what the code is saying is that epoch modulus 4. That means uh 4 divided by 4 equals to 0. So at every instance of 4, it will save the model. That's what is happening. So 0 divided by 4 is 0. So it saved the zeroth model. It saved the model as zeroth level. So it will save this fourth one now. It will save the eighth one. It will save the 12th one. It will save the 16th one, 20th one, and all of that. That's how it will keep, going on. So we're saving in touch.save. We are saving the model state and then save, this is the epoch number, right? And that's what you're seeing here on this file. If I refresh this, I should see model. Can you see model underscore 4? So I can take this model underscore 4, for example, and use it now, run something. Let me see. Okay. Let me see. How many epoch did I add there? What is the end epoch? Oh, 32. That's quite long. Okay, let's be taking questions as this guy is training. Let's be taking questions. So we have 32 epochs. So we want to save the models at each fourth iteration. So the goal is to see how, the diffusion model as model 0, diffusion model at 4, diffusion model at 8. And then, of course, we expect that the diffusion model at the epoch 32 would be the best, right? Because it would have, fine-tuned all those parts. So, yeah. Okay, cool. Yeah. The code maybe may want to form bad guy, but don't worry, just dive in, go through the comments. It's well commented. You will get a hang of it. You'll get a hang of it. All right. Questions. I think we should do something while this is training. Let's do a zero shot classification model using BERT. Zero shots. Zero shots. That would be very interesting. Mm, let me see. Mm, okay. This is a field mask pipeline. It's saying, hello, I am a. So here they're essentially trying to tell you that, hey, this guy can be biased, right? Uh, right. Okay. Yeah. Okay. This is where they are telling you about a biased part of the model, right? Pipeline, fill the mask, right? So they say, okay, here is the mask. The man worked as a, right? And then they put a mask. This mask is what it needs to replace with a, with another word, essentially. And BERT encoder is able to do this because it has a full attention span, right? It can see across all the words. When we did attention, the attention mechanism last week, the encoder could see all through the words, but the decoder has a maxed attention, right? So because the encoder could see all through the words, The encoder could be used to solve this kind of problem, for example, right? But not the decoder cannot. So he said the man worked as a first one carpenter, waiter, barber, mechanic, salesman. But check this out. The woman worked as a say nurse, waitress, maid, prostitute, cook, right? So the bias also affect the fine-tuned version of this model. So they're essentially trying to tell you that okay, yeah, you know, there are some biases within this model. So to change this to a I think let me see what is that task called? A few shot model, a few shots inference or a few shots task for classification. I think that should be called question answering sentence similarly. No, is it token text classification? Fantastic, right? So you want to do sentiment analysis. You want to do sentiment analysis and all of that. All you just need to do is to pass the pipeline, and then pass the sentiment analysis. Sorry, pass text classification here, right? And then say, what is the capital of France? Paris. This is really not okay. Hold on. Let me see what they're doing here. Natural language. Okay, this is natural language inference, not really sentiment. But I'm sure this could definitely be used as sentiment as well by changing the text. By changing the text, I could just say that, hey, uh, I'm happy about this class. What is the sentiment of this word, and then it's you to tell me whether it's positive, negative, or whatever. Just that's a zero shot. That's a zero shot method of using these models as classification to solve classification problems, right? Instead of having to do it in a classical way. So text classification, I walk to home when I went through the bus. Wow, this is some English. Okay, I'm not reading through this thing fully, right? Okay, it's testing for grammatical correctness. Fantastic. Okay, so this is testing for grammatical correctness. So this error was deliberate, and it was like, okay, this is not acceptable, right? This is zero shot way of checking for grammatical correctness. Text classification, if you would do it to say, okay, this is correct, this is not correct, traditionally that would take a lot of effort. But essentially, they just did the text classification by saying, by detecting the correctness of, words, in a zero shot way. That's what you're just saying here. That's grammatical correctness. And, used for inference, Cora question pair. I don't know. I've not read this myself. All right. So this is sentiment analysis. Oh, fantastic. This is sentiment. You pass sentiment analysis as the pipeline, and then you pass in the message. It tells you positive or negative. Like it is incredibly. It's like incredible power in terms of what you can accomplish with this. So just play with these. I think they should have Google Collabs. Let me see. Do they have Google Collabs for this? No, they don't, unfortunately. But just try to copy these codes, open a new collab file, and test them out and play with them, and what you can do with this. Mr. June, we discussed this is the power, that you're looking for. You can, create a system that would be able to generate, the intelligence behind the products you're building, essentially, right? This is it, right? So by using the pipeline information, do whatever it is you want to do, or by going after some specific pre-trained models that has its own processor, right? And then the processor methodology that the author of that transformer model has created, you will be able to do a whole lot of things, right? We didn't touch fine tuning of those models, but it is very, very easy and possible to fine tune those models by adding your own new data sets that wasn't contained in the original data sets as well. I will probably, share the Google Colab for that so that you can play with it. And all these Google Colabs will be available, in the notes. I'll make sure that you can, and it will be sent in the notes today. All right, so the training is okay. We have 0 to 20 now. We have 0 to 20. Awesome, thanks. All right, questions. We just want to see what the guy has trained. The guy that's trained, what he has for us, right? So once that training is complete, we will end the class, and that will be the end of the first cohort. It is a whole lot. We don't have enough time to touch the intricate part of some subjects, right? We just want to count on you guys to fill in the gap. You have the foundation to build from here, right? And how to do it would be to find a problem around you and build a small, start from the small function on Colab and then expand it, to now build a UI on it and then expand it to now build other things on it, right? That's how it should, progress. Don't have this gigantic, I want to build a ChatGPT vision stuff, right? Just start from a small problem. Okay, you have access to some information, and then this piece of information could produce more value if you could generate meaning from this information, right? What can I do with this, and what kind of work do I need to do on that data set to be able to generate, make that data more useful, more meaningful to the users, right? At the end of the day, that's what IT is all about. That's what information technology is about. It's about making data useful because data is surrounding us. It's around us, but we just want to, you know, make sure that the data is useful as much as possible to the owners. Look for problems around you. Look for things that you can play with, and keep messing with these collabs, keep building stuff, and you will get a good hang of it. And reading papers, I read a lot of papers, right? I don't know 1% of what needs to be known in terms of especially transformer models, because it is we have 100 new papers created every day because guys are not sleeping. People are pumping billions of dollars into this research every year. Billions of dollars is going in there, right? So you can just come in here and study some papers and see what new paper lately, right? You may not get everything of the paper is talking about, but you will understand a whole lot than if you did not read those. If you did not read the paper of the original Google guys, attention is all you need. You will struggle in terms of how they the pipeline, in terms of how they build the pipeline for that model, right? You will struggle. But explain the reason why they did, what they did, why they used this sine cosine function for positional encoding, right? Why? We could do other things, but why did they use sine cosine function? Why did they use multi-head attention? So a lot of those things are contained, in here. If you want to dig deep, right, it will set you apart a whole lot, a whole lot. There's a whole lot of papers that are coming out that I've not even been able to read, mostly on transformers because that's really what is new and changing the game for everybody, right? So if you can add that together with getting your hands dirty, messing on Google Colab with all these things, writing different codes, seeing whether it will work or not, you will, in a matter of few weeks, be better than the average Joe on the street on generative AI. Yeah. So I think we are done. We have all the model fully done. So let's refresh here. Let's refresh to see. Okay, fantastic. Can you see? We have all the models saved from 0, 4, 8, 12, and then 20, 33, 31. And yeah, so this is so the upper function removes the predicted noise, right? So the model, the DDPM predicts the noise. So and then it removes the predicted noise, but adds some noise back in to avoid collapse. What I showed you earlier was a collapse, in that image. So it adds just a little bit of noise right back to avoid that blob image showing. And, you know, uh, yeah. So now we simply want to load the first, we want to load the first model, right? Touch the load, model loaded, right? Touch the load, we loaded the model, and then we want to see all these plots. It's just to visualize what it has for us, right? It's just to visualize it. All this code from here is to visualize it, and to give us that timeline cadence. So in 32 steps, right? It will sample it for us in 32 steps. So let's see what it at model 0. Let's see what it has. Essentially, that's what we're doing here. Okay, this is where it is now. It's trying to render the visualization. It's trying to render it. Fantastic. So this is what we have at model 0, right? We have noise, and then we remove predicted noise, but added a little bit more noise. Remove predicted noise, added a little bit more noise, but at the end of the day, we didn't have the right image. This is model 0. This is model 0. Let's go to model 4. Model, you can keep changing it, but let's go to the model 31 real quick. Let's go to the model 31 real quick. I'm skipping the other one. You just notice that at the end of the sample would be better as the model gets trained. We saved all the models right here. The end will be better. So the end of the model is 31st. 0 to 31st. So let's just see. This should be really, really good. So you can check out the GitHub repo and learn more about diffusion model. There are other models. There are other techniques of doing removing noise from diffusion models, right? But this is just one. This is how it started, right? There are better ones. It's slower, but it's better. So there are better. There are other techniques that are faster, but they generate less quality images, right? So here is the new one at the model 32, model 31. So we loaded the model, right? We loaded the model right here, and we're trying to visualize what it has at each sampling point, right? The pure noise, it removed the first, predicted noise, but added a little bit more. Remove the predicted noise, added a little bit more. Kept doing that until the images started to emerge. So this is how it would have worked if we had trained it on images of cars, images of airplane, images of houses, images of all these things, right? So this is how it would have been able to still do it as well. But this is just like a way to just explain. This is an explainer, right? And lastly, trust me, this is the last point that I will be making. I have another notebook here. You know, so this notebook allows you to now use a lot of. This notebook allows you to use a lot of transformer models together without you specifying anything, right? And I'll quickly demo it to us. Customer can do anything. That's what it's titled. There's a whole lot of codes from it that came from the Hugging Face guys, but it's just like, put together here. So I'll just demo a few things right here. So I'm installing Transformer. I'm installing Transformer. So it will ask me to do notebook login. This is the code to, log in and ask me. It will ask me for my token. This is the last bit of demo. So you can copy the code, lift the code, take it to your application, your system that you would, need the code. And it's the same code, it will work, right? And, build whatever you have to build, and who knows? Maybe the next one that we just see Steven has raised 100 million US dollars from YC or from whoever. Okay, so I've just installed Transformer. I installed it from Git this time, and then did notebook login so that I can, use some login face functions, right? So agents, agents are like agents are like brains of how do I explain it? Agents are like brains that reasons what should be done. Now you see all the code that we have done to do all these things. Text to speech, speech to text, generate this, generate that, right? But the agents can write the code for you behind the scenes, as a matter of fact, right? But to do that, let me quickly do this, right? Let me use OpenAI. OpenAI agent is the best because what it does, what the agent does is that it will write the code for you, and the code will run to do what you want it to do. Stay with me. Let me just demo this real quick. Let me get my OpenAI key rather. Where did I put that? OpenAI key. Okay, this is one of my OpenAI keys. All right, so it's asking me for my OpenAI key. The reason why this is important is that it will call OpenAI to say, okay, for example, stay with me. I say, create an image of a turbo engine plane in the water, right? So it will. I'm not telling it what transformer model to use, what anything to use, and I'm just asking it, create an image of a turbo engine in water, right? Actually, what in the original code that the Hugging Face guys wrote is a boat that was there. That's why the variable was written to boat, right? But let's leave it the way it is and run this. What it will do is that, what is it saying? Excuse me. Incorrect API key provided. Why? Why is it incorrect? Third. Third. Okay. So, okay, fine. I think it's working now. All these whole transformer model that we are writing the code and all of those things, it will write the code by itself and run the code and give us what we want. Right? That's what agents do. Agents are like brain. So you say, I will explanation of from the agent. I will use the following tool, image generator, to generate an image according to the prompt. Right? Code generated by the prompt says image generator, prompt, turbo engine plane in the water. Right? So this image generator has some other implementation within it, blah blah blah, that will now carry out that instruction, right? So this has been done by the organ face guys to kind of like abstract these things. I think they have about eight things that agents can do. You can translate from voice to text to voice, and then text to image, and by just writing something like this. So imagine you at the mid journey of today, right? You could simply, pipe your imagine a boat, blah 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 blah, to this kind of function, and then you create the image for them, right? So this is what is happening. Wow, I don't know what kind of plane this is, but this is not bad. This is not bad, right? So that is, he wrote the code and then gave us the image. I'm not the one. I didn't write any code. I just write agent. I imported agents, right? This agent is from HF agent. They say there is a, where did I import that? Imported it somewhere. Excuse me, show code. That's what I wanted to do. From HF agents, right? From transformer.tools, import HF agent, right? And then that HF agent is now has the model, that is thinking, doing the thinking. Okay, for me to do this, I need to do this, I need to do this, right? Right. So there are other types, stack coder and then open AI assistant, but they are not that great in terms of their brain is not correct as ChatGPT. That's why I'm using ChatGPT here. Yeah. So um, and then this is the agent that I'm saying, agent.run, right? That is coming from HF agent or open AI agent, right? So agent.run, and then it gave me the plane. If I run it again to give me another image, right? From the first demo of generative AI that we did, we were the ones that wrote the code that did all those things and then it gave us those pictures, a man riding on a horse. But now the AI is writing the code and running the code and giving us the results, right? Within the notebook. Very impressive, isn't it? Right. So you can play with this as well. Um, Try to play with it. Fantastic. This is better. This is better. Wow. Wow. The wings are looking funny though. The wings are looking funny though. Yeah. So now look at this. I say there's a boat image. I pass in a variable boat image, and then I pass in the boat here, right? And say, can you explain the boat image, which is of course the variable here? If I run it, it will caption it. That whole code that we did as assignment last week, image captioner, bleep and all of those things, right? It will write all the code to caption the image by itself and then give me the text. As straightforward as that. A small plane flying over the ocean. That is the caption. A small plane flying over the ocean. I didn't write the code. I didn't even do anything. I just say agent or run and then passing the stuff, and then he wrote the code and then give me my answer. Right? You know. So now I say, can you generate an image of a boat? Please read out. This is powerful, right? Please read out loud the content of the image afterwards, right? So if you know that, okay, first I will need an image generator. After doing an image using image generator, I will now use text reader to read out loud the content of the image. So see, use an image generator, use an image captioner, and then now use the text reader, right? I didn't write the code. I didn't write the code. I just spoke to the guy, and then he wrote all the code. And if I run this, that's essentially what will happen again. So if I used other agents like the stack coder, they are not as smart to understand very complex problems like this, because this is like 3 layer. Generate an image first, now, caption, I didn't even say caption the image, but it knows that for it to read out the content of the image, it needs to caption the image, right? So this is where some of the stakeholder, the open AI assistant, this is where they fail, right? They could not solve this problem very well, but open AI achieved this state of the art results in terms of being able to generate the code, the correct code. And then the agent that runs it, and then you have an audio. You have an audio. Where's the audio? Ah, oh, interesting. Okay, you guys cannot hear what he's saying. Let me download it. I'll share it. I'll share the download later. I'll share the download later. So you could ask it to do anything. Read out the summary of this hf.co, and then it will download the stuff. See, it says text downloader. It needs to go to the URL, download the text there, and then use summarizer. Summarize the text, and then it needs to then read out. Use text reader to you read the summarized text, right? And then you have the summarized text. Like it is which this is Edu, people working on generative AI. So this is the future. This is the future, and this is why we were saying that this guy is technically going to disrupt a whole lot of people because now it is in primitive stage right now. We this year it's just the only year that we've had tremendous progress in transformer, AI. Imagine what happens in the next 5 years. Even though we've had transformer around since 2017, it is just last year that they started catching up and people started building stuff on them. Imagine what happens in the next 5 years, right? So massive disruption is actually expected because now I'm able to get results without even knowing how to code, right? I don't know how to code. I'm just telling me, show me the picture of this thing. Okay, translate this thing or text, and then it's giving me the response. I didn't write the code. It wrote the code, and then just giving me the output that I can understand. That's a non-coder, right? So that's really a powerful thing that is possible with generative AI. Yeah, awesome. It's a very long one. I just wanted to touch on as many things as possible. There are a lot of things I still cannot catch up, that I still cannot discuss just because of time. And we don't want to make, the class continue, right? We just have to, end it somewhere so that, we can trust the we can trust you to take it on from here. There's a whole lot we didn't touch. There's a whole lot we cannot afford to touch because it's a rabbit hole, right? So we want you to start digging deep and start coming up with questions, and let's see how we can take the journey on from it. It's just the beginning of the journey, right? There's a whole lot that is actually possible or available for you to do. Thank you so much. Do we have any question before we end the class today?
Okay. So, Mr. Israel, thank you very much for the insights and for the training. When is the hackathon starting, and how do we form teams? How do we get to meet ourselves, and what's the way forward from here now?
All right. So the hackathon, we are scheduling it for some time. The date is not concluded yet, but we are, hoping it to be late November, early December, very very early, first week of December, late November period. We're putting together, things that will ensure that it's, uh, that it's a successful event. So you can form team anyhow. We just require that a member of the team must be a member of African AI Foundation, a student of African AI Foundation. You can form, the rest of the team can come from, you can collaborate with other people outside the foundation, right? Uh, but someone within the foundation must be within the team, right? So it's pretty flexible. So build out anything. If it's if you are only able to build out, if you're only able to build out, something on Google Colab, that's okay. If you're able to build out something that has a front end, a UI that you're able to host it on organ facing friends, that's okay. If you're, no matter how sophisticated it is, it is okay, right? So what we would try to do is to, give you themes, but you can pick up any interesting problems that you find, right? But know that you'll be competing against other people that their ideas may be much more interesting, right? So we can give you themes to kind of like help you focus your attention in terms of where to look for problems to to solve, but you could pick any problem to solve at the end of the day to build. Yeah, Dr. Tolu, it's open. It's open. We would definitely create teams, but it's open. Define a problem. I want to solve. I want to solve for pick that problem and solve for it. Right? Use all this knowledge. Use transformers. Use agents. Convolutional neural network. Use UNet. Use all these things. Right? All the codes. You have all the codes. Right? Steal them, copy them, and win. Awesome. Alan, please go ahead.
Hi, mine's a two part. The first one is I have quite a few friends who are in the diaspora and in Kenya who would like to join the next cohort. I wanted to find out how they can join and when that will be available. The second part is I'm a bit behind for personal reasons, and I'm trying to catch up. So I don't think I'll be able to join the hackathon. But how can I still be able to join? Be able to like post my questions in the same Telegram groups to catch up and try and see if I can be able to be more useful to the foundation.
Absolutely, absolutely, 100%. It's open. We will keep it. It's going to be partially open. So you can, in months, hit a roadblock while running your codes, while doing some things. Put your question in there. You, concerning your first question was the starting date for the next register around May, June next, possibly earlier, but you'll get a communication. You'll get a, if you're within the, Telegram and all those things, you could even, forward it to your friends to join. It's possible that it's earlier than that, but we are, thinking it to be around May, June of next year.
Is there anything they can do to prepare for it? Like, should I share the same videos from this cohort to them?
Beautiful. Yeah, it is open. Yeah, so that they can actually, be in the mood before
Yeah.
the actual stuff starts. Yeah,
Thank you very much.
sounds perfect. You're welcome, Alan. Questions, questions, questions. So not to worry, the class note for the last class will contain all these codes, all these Google Colabs that contains all the codes of what we've done today. The DDPM, the demo, solution to the assignment of last week, and the agents, the transformer agents, and you have access to all of them as well. Thank you. It's been a pleasure, walking through this journey with you guys. And let's see what you do with all this knowledge. If you don't do anything with it, you'll forget it because it's too nuanced, right? You can easily forget. How to not forget is to build something with it, right? So we can wait to see what you build. We can wait to collaborate. The foundation is actually open. The foundation is working on a whole lot of projects right now. The foundation is working on a whole lot of projects, and what we'll be doing is actually picking some of the best candidates from this class, giving them a role in the foundation so that they can actually help push some of the courses and the projects we're working on. And people are bringing projects to the foundation as well, right? We have entrepreneurs in the room. Mr. June is an entrepreneur building stuff. Crazy, mind-blowing stuff, right? If you if you hear is what he's building, right? And it's only AI that can solve it. That's why he's in the class, right? So thanks, Mr. June, for participating, right? So people like uh, you know Mr. June and other entrepreneurs are bringing projects. So if you're looking to collaborate to, help build AI systems that's, that will solve some specific problems, you just sign some, non-disclosure, non-compete, and all those kind of legalities, and then get into the mood of building, because that's actually how you can perfect, what you've learned. If you don't practice them, you forget in no time. Yeah. Mr. Emmanuel?
Okay. With regards to what you just said, fine. I like the idea that we're open to opportunities. But what I've said, maybe we can take it a step further. Do you have like something like internship programs like that we can just, those who are ready to keep their hands steady, those who are ready to code, who are hands-on, who are ready, who want to actually do things,
Yes.
and they need a platform to like even showcase what they've learned, aside from the hackathon. Are you
Yes.
making any
Absolutely.
available in
Yeah,
such
that's
systems?
actually. Thanks, Mr. Emmanuel.
Because
Yeah,
I'm interested, though. That's what I'm asking.
okay. Sure, sure. I mean, yeah, absolutely. That's actually what I mentioned. We will be contacting, top contributors and top commenters, top, that will be interested in internship, definitely, over the next couple of weeks to months, depending on the projects that we have, within the foundation. Absolutely. Yeah. So reach out.
You can
Also,
limit about the hackathon story. So I
okay.
know this is the end of the class. What is the expectation now from now till the end till when the hackathon is supposed to start? Are we supposed to now try to figure out a project to work on, start trying to, and then are we presenting it at the hackathon, or like is that supposed to happen when we meet? Like I'm still kind of confused about those details.
Oh, got it. Okay, no problem. Yeah. So the problem sets are flexible. You could, pick any problem sets. You could start building your team right now, because we believe, you could pick a very tough problem that will require extensive period of time to solve. That's why, it's like a month long kind of hackathon, right? So the actual hackathon event is just for you to, demonstrate what you've built. Imagine you're doing your custom fine tuning, you're doing, solving some Africa, related problem where the data set is not, available, you know, globally, right? You would have to do some fine tuning, to be able to solve this kind of problem. So those kind of problems, it's not something you would do in 6 hour kind of hackathon, right? Or in a day kind of hackathon. That's why we have a month long period. So as it is right now, you can be, working on anything that you think should excite the judges, and you may just be the winner. So it's pretty flexible and open. We believe that 1 month should be enough for you to even learn anything, a new concept, that you haven't figured out, and be able to apply it within the hackathon, and then build something that would be incredible.
So we're expected to now go and work on something and present it at this hackathon.
That's right. Yes.
I feel like potentially like a meeting where we can share what we're planning to work on, maybe like a proposal or something where we can get some of the details.
Oh yeah, so there will be a link. There will be a link where you will be able to register your team, and then you'll be, that's how you'll be putting the problem you're picking to solve, and to be a little bit more organized, not like, wild west fully. Yeah,
Okay.
so you register your team, you register all your team members, and then you define the problem sets, a brief description and all that. Yeah,
Okay.
cool. Mr. Sabo, yeah, on the certificate part, so we wanted to, issue, a certificate that we carry American corner, especially, because of the weight, the name, the brand, and all of that. But it's not something we are able to do at this time, unfortunately. You know, we're not able to do that right now. At the end of the day, it's the knowledge that matters, So no matter where you go, if it's about what you can do, now you should be able to build a regression model. You should be able to build a convolutional model, a convolutional neural net model. Now, you should be able to, work with a pre-trained transformer model as well. And now you should be able to also, at least you should have an idea of a diffusion model, and now you should have an idea of, a transformer agent actually as well. So it's the knowledge that matters. But we will be working towards issuing a certificate of attendance in the subsequent cohort. Mr. Manuel, you have more questions?
Yeah, the hackathon. I would have suggested that maybe on the forum, because instead of looking outward, like going to look for external persons to join a particular team, why not we in this forum, like those of us that pass through this cohort, we get to introduce ourselves, get to know ourselves. Maybe we'll just form a team amongst ourselves there, so that at least even those who have not been able to pick up, while we're collaborating on the project, we will, it's going to be like a win-win for everybody. We'll get to learn more, as a team we bond. Then, from there, we don't know what's, the sky can become the stepping stone. That's my own
Absolutely.
suggestion.
That works, but we don't want to limit it to the team alone. To the people within the uh, foundation alone, because we are not confident of availability of everyone. A lot of people are catching up with the recordings. You see that mostly we're 15 during live calls, 10 between 10 to 15, sometimes 20 on live calls, right? But a lot of people catch up with the recordings, and uh, so availability, guaranteeing availability of all members may be tough, and closing it to only internet team members may not allow us have participation as we may love to see, right? So that's why we're opening it up. If your team members are all AIF members, absolutely fine. That's even better, right? But if not, please feel free to collaborate with other people. Any more questions? Questions. All right. Thank you. Thank you so much. So it took 3 hours today, but I hope it's worth it. I hope it's worth your time. Again, we could not touch on a lot of things. Let's burn the midnight candle to dig deeper by ourselves, and I'm sure we would build incredible stuff. Would have massive capabilities to solve some really interesting problems in the subsequent months. Thank you so much. Dr. Tulu, do you have any last words for the people?
Um, can you hear me?
Yes. Audible.
It's been a journey. It's been, and first of all, greatest appreciation to Mr. Israel, greatest appreciation to everyone that has made consistent attendance to this learning. It's not easy, right?
Not.
And especially having the self-discipline to always want to learn, and something triggered a sense of fulfillment, asking questions about we want to keep getting our hands dirty, we want projects, we want to keep tapping into this, and seeing the seed that we've planted, seeing it germinate into this strong desire is something rewarding from our perspective. And we want you to we want this hackathon to be the the icing on the cake, to see all the knowledge
all the knowledge impacted, how it can, bring something to life, something applicable, something long lasting, a start of a legacy, So, first and foremost, I'm proud of everyone, right? We know how we started, how the quantity of people that started, and the last men standing or women standing, right? So, thank you. As regards the hackathon, just feel free. You have us on Telegram as advisors on the project. We are here, and I will be. You have me on Telegram and on WhatsApp. I will be in touch. So please, thank you very much once again. God bless everyone. Thank you. And thank you, please, to our tutor, 10 weeks, right? 10 or 11, I think 12 weeks of his time to
So
Israel. Wherever you are, muted or not, a round of applause to, Israel. Come on. So thank you, everyone. Yeah.
don't mind him. It took 5 or 6 out of the 12 weeks. So I mean, thanks to
Okay.
Dr. Tulu as well. Thanks to everybody for joining. You made it worth it, and let's do greatness.
Yes. So let's keep in touch too.
Awesome. Thank you all. Have a very good one. Bye.